My name is Iago Portela. I am process consultant at TripleAlpha, and now I'm going to present a project that we have developed at TripleAlpha for a company in the mussel sector. This project involved the development of a prescription dashboard for the mussel purchase and production processes. First of all, to give you some context, I'm going to introduce what we do at TripleAlpha. We are a company specializing in data analysis focused on the industrial sector, more specifically on the agri-food sector, such as the mussel industry. And what do we do? As stated on the slide, we help our clients in the processes of generating, managing, and analyzing their data to extract the full business value. In other words, we cover everything known as the data value pyramid, from data extraction and collection, the transformation and organization to turn them into information, and finally, using data analysis techniques generates knowledge that helps our clients make decisions. This is our team. It is structured into 3 main departments: an area of operations and process analysis, which is composed of the people that you can see in blue. All of them are industrial engineers. Data analysis department, the people that you can see in orange, composed of data engineers and data scientists. Most of them are physicists or mathematicians. And finally, the systems department, comprised of computer scientists and telecommunication engineers, and is the people that you can see in purple. Having introduced TripleAlpha, now I'm going to present the project I said before we have developed with this company in the mussel sector. To do so, I'm going to present the roadmap that we use in almost all our projects, and that consists of the 4 stages shown in the slide. Sorry, because the slide is in Spanish. And the 4 stages are: identify your KPIs, collect data, structure data, and finally extract value from the data. First of all, we start by identifying the KPIs. To identify these KPIs, the first thing to do is to define the technical questions that we want to solve. In this case, are those shown on the slide. For example, what type of mussel is of interest to us in terms of yield and profitability? Where and when is that mussel grown? Is there a difference in profitability for the same type of mussel among different areas, ports, or producers? Once the questions to be solved have been identified, the KPIs that allow quantifying or measuring the impact in the different cases to answer these questions are defined. In addition, a Ishikawa diagram, as shown in the slide, was developed for each KPI, with the objective of also identifying the key variables that influence each indicator. The next step is to collect the data of the different variables identified. In order to obtain the data on all these variables, the first step was to identify the sources of information of the company. In this case, the data came on the one hand from truck delivery notes, cooking and freezing orders, and the work report, and on the other hand from the company ERP. The first data were collected in paper format, so it was necessary to develop web forms to automate the data collection and then integrate this data together with the ERP data in a cloud database. In this slide is shown the data architecture developed for this project. Once the data collection is automated, the next step is to structure the data in this database. Following the pyramid of data valorization, the first step was to clean and organize the data to transform them into information. To do this, we had to prevent duplication, simplify variables, ensure format consistency, standardize the names of rafts and areas, remove redundant information, and eliminate yield values equal to 0. Then the next step was to structure this information in order to analyze it and generate knowledge for the company. To do so, we took the following considerations into account. Consider only those associations, areas, and rafts that contribute to 80% of the productions, the 80-20 rule. Identify deviations in yield samples between dock and plant. Remove data from rafts and areas with little historical data. We only use those with historical data since at least 2018. And remove data from rafts that appear in more than one area, as the correspondence should be unambiguous. Once this is done, the last step is to extract value from this information. That is, to generate knowledge that allows the company to make decisions. Based on the initial questions that I saw in the beginning of the presentation, the objective of this project was to determine the purchase area, the supplier, the season of the year, the type of mussel, etc., that maximize the yield and profitability of the company. That is, to identify these maximums of yield and profitability. To determine these maximums, the first step was to do an exploratory analysis of the historical data. First, to whom the mussels have been historically purchased, what area mussels came from, and what time of the year the mussels were purchased. Specific analyses were then performed combining these three data fields. The first analysis focused on determining from whom to purchase the mussel depending on the time of the year. This analysis and the model developed shows the following conclusions. Suppliers generate losses in spring and the better results in autumn. It is better to avoid working in winter and try to negotiate with associations in summer. Abensa, which is one of the suppliers, is profitable at all times of the year. All suppliers report profits in summer and autumn months. The following analysis focus on determining in which area, in this case area, non-supplier, the mussels purchase the mussel depending on the time of the year. From the results obtained from the development model, we can obtain the following conclusions. Generally, it is better to avoid working in winter. It is most profitable to work in autumn. Ribeira B is the only one whose production stands out in winter. And finally, in general, all areas report good results in the summer and autumn months. The results here are similar to those on the previous analysis. The last analysis focused on determining where to buy based on the supplier. In this case, a heat map was carried out from which we draw these conclusions. For example, Abensa generates profits in practically all the areas where it works. Muros Noia only generates good results in Ribeira B and Promar in Ribeira C. It is better to avoid working with Virse do Carme in Caraminal D and Caraminal G, or it should be known that Ribeira B and Ribeira C have good results regardless of the association, and so on. Finally, I am showing the dashboard developed to visualize the impact of the results obtained in the customer's plant, showing the productivity, yields, and profitability depending on the area, the supplier, time of the year, type of mussel, etc. But sorry, I won't go into more detail as it is a customer dashboard. And this is all. Thank you very much for your attention, and I hope you found it interesting. You have my contact data at the bottom of the slide.